Good morning, everybody. I think we'll make a start now. I was just waiting for people to arrive. Welcome to this talk this morning, which is going to be delivered by Sam Williamson. I'm Claire Eatock and I'm from the faculty's Industrial Liaison Office. If you have any questions for Sam today, there will be a Q&A at the end of the presentation. Please submit any of your questions you have in the Q&A tab that's found at the bottom of the Zoom screen. This talk is part of our week-long faculty research showcase event, which is really to demonstrate the breadth of our research across the faculty and hopefully to provide a stimulus for some conversation afterwards. And without further ado, I will hand over to Sam, who's going to talk about energy and the Sustainable Development Goals. Thank you, Sam.
Thank you, Claire. So hello and welcome. My name is Sam Williamson. I'm a lecturer here in electrical engineering and a member of the Electrical Energy Management Group and Engineering Systems and Design in the Faculty of Engineering. I'm going to be discussing with you today about the impact that energy access has on the Sustainable Development Goals and through the use of 3 research project case studies that we're working on here in the University of Bristol. Before I start, though, I would like to say that I work alongside a team of researchers in Bristol working in this area. And so just to sort of let you know who they are. So Joe Butchers, Charlotte Ray, Peter Thomas, Will Clements, Daniela Rossard, Pablo Newbury, and John Maloney. And not only that, excuse me, we work closely with our international partners to co-produce our research on these projects. So some of our partners are PIDA in Nepal and CAPEG, also in Nepal. Nepal Yantrashala, Jadai at the Federal University of Pará in Brazil, and the Mamiroas Sustainable Development Institute, also in Brazil. The projects we work on are very interdisciplinary, and we have researchers working across social and physical sciences and developing understanding in fields cultural, economic, policy, to try and make sure we've got a wide-ranging impact of our work. Firstly, I would like to introduce you to the 17 UN Sustainable Development Goals. The SDGs are a blueprint to achieve a better and more sustainable future for all. Their aim is to try and address the global challenges we face, including those related to poverty, inequality, climate change, environmental degradation, peace and justice. The 17 goals are all interconnected, and in order to leave no one behind, it is important that we achieve all of them by 2030. Within each goals, there are individual targets, and in total there are 169 targets to achieve with their own timetables. Sustainable Development Goal number 7 is to ensure access to affordable, reliable, sustainable, modern energy for all. And within this, excuse me, there are targets to ensure universal access to modern energy services, increasing substantially the global share of renewable energy, and increase the rate of energy efficiency. So why energy? Why is energy important across the Sustainable Development Goals? So research has shown that working on these targets can also actually support the achievement of the other Sustainable Development Goals. The research paper here by McCollum has shown that there's a strong positive enabling environment across all the goals from access to energy, such as if you have access to energy, then you've got a better support for basic housing and transportation services, impacting Goal 11. But there are some small counteracting issues as well, such as those with the competition between bioenergy and food. It's also worth saying that not all energy access is equal. A household that transitions from kerosene lamps to solar lanterns is likely to feel an improvement in their situation, but it's not necessarily going to be transformative. Even a connection to the grid may not provide the support needed for true transformation if that grid supply is not unreliable. Therefore, alongside this sort of traditional access measurements, the World Bank has also developed a tiered level of access to understand the availability of these services as well. And these go from this tier 0, where you are using traditional forms of energy, to tier 5, where you have 23 hours of energy access, both day and night, and multiple services on that. So over the next few slides, I'm just going to take you through these 3 case studies that we're currently conducting research into. So these are electric cooking, DC microgrids, and design for localization. And we'll look and see how, at the end of each of the case studies, how they relate to the Sustainable Development Goals. So first of all, I'm going to talk about electric cooking. So in our electric cooking at the moment, our research at the moment is taking place in Nepal, although we have just started a little project in the Gambia as well. In Nepal, 22,000 people die each year from indoor air pollution. And worldwide, the number is around 4 million. In rural areas in Nepal, about 85% of households cook using biomass. And the burden of this firewood collection is almost always falls on women and girls. So you can see here an image of a young girl carrying some firewood back up to her house. I have met teenagers in the hills of Nepal who carry 25 to 30 kilos of wood from the nearest forest up to their homes. And so they have to travel quite often long distances and are exposed to risk of physical and sexual violence as well. This constant collection of firewood also leads to deforestation, and they need to walk further then and potentially degrade the environment further. So working with our partners in Nepal, we're understanding this complex transition from a biomass-based cooking system to electric cooking. There are not only technical challenges within this, surrounding the supply capacity and also demand management, but also as cooking is a very highly cultural act, it can be very difficult to change habits over time. So we're actually currently in our third cooking study in Nepal at the moment. Over the last two and a half years, we've conducted a number of cooking studies. Our initial studies, we assessed the potential for electric cooking appliances to be used with Nepali cuisine to understand this sort of relationship between how you cook and what devices you have to cook with, as well as the impact on the electricity supply system. We provided training for the households, as you can see here on the picture on the left, how to use the new appliances. And they used a diary methodology to be able to try and record the change in their habits, to understand how they went from their biomass cooking to the electric cooking. So across these cooking studies, what have we found? So we found that electric stoves were actually quite well adopted by the communities we worked with. And they were able to cook most of their own preferred meals on them. One issue we found was cooking chapati that quite often burnt in the middle and was raw on the outside. And talking with colleagues who work on electric cooking around the world, they have similar issues as well with cooking chapati. We also found that households actually like to stove stack, and stove stacking is where they use multiple different types of stoves. So quite often they're using the electric stove, but also their biomass stove as well, which meant they could cook a bit quicker, but also they could cook things. If the chapati weren't working on the electric stove, they could cook the chapati on the biomass stove as well. Our analysis from our cooking diaries showed that households are using 20 times less energy when cooking with electric. And this is due to the inefficiencies within biomass-based cooking stoves. And for a 2-week period, the electricity for this cost under $3 US. If they had purchased the wood, which often a lot of households don't, but if they did, and if they had taken into consideration the time or the cost of their time as well, for a 2-week period, they would have been spending about $7 US. And so there's a real cost saving for these households and communities. There was obviously a considerable increase in the use of electricity, as we can see in the graph on the right here. And this was only for 10 households within our community, when there are potentially 1,000 households that could actually connect onto the grid and cook with this. So there's some real technical challenges to solve for this in terms of demand side management and also energy storage. In terms of the impacts to the other sustainable development goals, this project showed strong support for reducing poverty and improving health. We had feedback from communities that they really enjoyed having this smoke-free kitchen, and that pregnant women really appreciated not having to go and collect firewood. It reduced gender inequality because, again, women and children weren't required to go out and collect firewood, and encouraged a sustainable use of resources and the conservation of and sustainable management of forests. So that's our first case study of electric cooking. The second case study is looking at the electrification of a small community in the Amazon rainforest, about 30-minute boat ride from the nearest large city, using a DC microgrid. For those who don't know, a microgrid is a combination of electrical sources, loads, and storage elements that can work together to provide a service. The target communities in the Amazon are often farmers or fishermen who need to sell their produce at markets away from their community. If they have access to electricity, it's often through generators, which are noisy, smelly, and actually the diesel costs are about double the price compared with the city. And so quite often they can't afford the increasing costs for diesel. The benefits that electricity can bring to these communities are not just in lighting, but in processing their produce, which can actually then achieve double the price paid at the market, or keeping the produce cool, for example, for the fish. So working with our partner, Jadai, we tested a DC microgrid in their outdoor laboratory, comprising of photovoltaic generators and batteries that were located in different places across the grid. Then we implemented this system within the small community and used it to power a refrigerator and an acai processing machine. And you can see the processing machine working here. And as I say, you can get double the price for acai once it's been processed than you could from the berries just themselves. As well as processing the produce, getting it to market is also really important. And so Jadai have developed an electric boat that can actually be included within the microgrid, acting as a storage element, but also as a usage at the end of it. And this can provide transport to the city to reduce their dependence on diesel within the community. And so this is just their boat running in the river nearby. And you can see it's very quiet as well. Again, if we reflect on the impacts that this project has on these sustainable development goals, you can see it demonstrates a reduction in poverty and also improvement in agricultural incomes because you're able to process and get more money for what you've got. It provides relevant local skills because we're using local machines and local technology to be able to improve the situation, and sustainable practices. It develops a local economy and sustainable infrastructure, and sustainably uses natural resources as well. So the final case study I wanted to talk to you about today is looking at a technique which we've proposed here in Bristol called design for localization. So this is built on the concept of using open source material with local modifications for the environments, not only natural environments, but also industrial environments, social environments, cultural environments. We've researched this through the development of a new microhydropower turbine design for Nepal. So microhydropower in Nepal is used to provide electrification for many off-grid communities. It's been incredibly successful with over 3,300 sites implemented over the last 20 or 30 years. It uses local manufacturing companies to construct and install the turbines. However, at the moment, they only use two types of design, the cross-flow and the Pelton. And so this doesn't enable a full range of flows and heads of water to be used to be able to extract the energy. So initial research showed the possibility that a new turbine design could be used called a turbo turbine. And you can see pictures of these the turbines here. As you can see from these images, the design is actually highly complex and quite difficult to manufacture. So that requires a well-appointed workshop. So we developed a method to be able to understand the design better and try and be able to simplify it to be built in Nepali workshops. To do this, we analysed the manufacturing techniques available within the workshops, and working with a manufacturer, we proposed a new design to be able to meet these capabilities. We initially tested the turbine at scale in the laboratory at Kathmandu University, and it showed good agreement with our calculated power output. And then we tested it at a scaled test site just outside the Kathmandu Valley. Again, this test site demonstrated that the turbine can offer a good opportunity for different flow and head ranges compared to the standard Pelton and cross-flow turbines. And so at the moment, we're constructing a larger scale demonstrator that's going to be built in the east of the country in Taplejung. And this is going to be up to about 30 kilowatts. And you can see the turbine runner here on the right-hand side. And we're hoping that this is going to be installed within the next 3 to 4 months. So using this example of the turbo turbine, we drew, and thinking about the design for localization concept, we drew three main processes that should be used within design for localization. So first of all, deriving local requirements. So understanding what the local requirements are and how to be able to work with those. And then developing a solution for local industry, understanding what the local industry capacity is and be able to try and build on that and use that. And then finally conducting field testing to ensure that it was appropriate and it met with your requirements. And all of these things we think are really, really important to be able to work with local industry, to be able to develop local and appropriate solutions to anything really. And so now we're looking at different ways of applying this methodology to different technologies, such as power electronics. Again, if we link back to the Sustainable Development Goals, this project has impacts across several different goals, including developing relevant skills and facilities for the local economy, thinking about education, enabling economic diversity and productive activities, think about sustainable infrastructure and small-scale enterprise, and empowering economic inclusion, strengthening and scientific and technological capacity within the local community. And so all of these projects have got a wide range of impacts outside of their sort of accessing reliable, modern, sustainable energy for all, which I think is really key to be able to try and develop energy as a system. So to conclude, there are generally positive correlations between the access to energy and the achievement of Sustainable Development Goals. It is important to recognize that energy is not only about accessing energy, but it's the correct amount of energy that can be used to provide services to carry out daily activities. Again, if we think about the Amazon DC microgrids context, it wasn't that they couldn't access energy, but they couldn't access the right amount of energy and they couldn't use it to be able to generate more income from that. To be able to be successful in the projects, we have to have interdisciplinary teams to not only provide this sort of technical understanding about what's going on, but also to give a clear background to the social, economic, and cultural environment that the project sits in. Within our electric cooking project, this is really key to be able to understand actually what do people cook, how do people cook, when do people cook, and why do people cook, and what is important within that. Finally, these projects have been successful because we co-produce our research with our partners. We work very, very closely with them, and we've developed over the last number of years very, very strong relationships with them. And so we're able to work closely and develop this sort of strong appreciation as well of each other's skills within that. So I'd like to thank you all very much for listening. I'm really happy to answer any questions as best I can, and I'll hand over to Claire, who's going to manage the question and answer.
Thanks, Sam. So we have a first question to start with from Hind, which was, how much does it cost to introduce and run electric cooking in a house in Nepal?
That's so I guess it depends on what you have to do to be able to or what you have to install. If all the wiring is all fine within the house, then the cost of the appliances is about $50, or depending on what appliances you include, but the cost of a hot plate is about $30, something like that, and another $20 to $30 for the pans and things. We've also been looking at electric pressure cookers as well, and they are $40 to $50 in Nepal. And so if you've got the electrical infrastructure there already that's good enough, then I say it's about $50, something like that. If you need to rewire the house a little bit to make because you're going to be drawing larger currents through the wiring and you want to have more appropriate wiring and safer wiring, I guess, then a little bit increase on top of that.
And following on from that, actually, the next question is, what happens when the electrical grid or other elements break? Is there somebody locally who can repair it?
I guess that's part of the wider project and trying to make sure that those pieces are in place. So one of the things that we're investigating at the moment is what other pieces need to be in place to be able to ensure that if there is a grid breakdown, then it can be fixed as quickly as possible. That was one of the issues we found in our first cooking project, was that the grid actually was very unreliable. and quite often fell over. Excuse me. And so the households were actually just reverting back to their original biomass cooking stoves. And so from that, we learned that we did really have to try and make sure that all of that sort of capacity and infrastructure was there, and that support was there to be able to enable the electric cooking.
Thanks, Sam. Michael has asked, are there any downsides with not collecting firewood, for example, rotting wood accumulation?
I'll be perfectly honest with you, I don't know. I imagine there are, as you say, there's things like that, but especially in Nepal, and so in the sort of area that I'm aware of, a lot of the time the forests are managed by a community forest sort of organization, and so I guess there would be a bit more, there may be a bit more for the community forest organization to be able to sort of deal with. But in terms of the environmental issues with that, I'm afraid I don't really know. It'd be something interesting to find out though.
Yeah, definitely. Stephen has asked, how do you ensure you sustain a culture, which is one part of the sustainability development goals that's not always considered? Disruptive technologies like this can also disrupt cultural practice.
Yes. It's a very difficult balance, to be perfectly honest. And I don't think I necessarily know what the right answer is, but I think from the experience we've had over the last, well, the cooking over the last few years, and my experience over the last 10 years working in sort of international development-based research, you have to work with the communities on the ground, and having those international partners that are community-based organizations, I think is really, really important. And so I've been working with PEDA, well, for the last 12 or 13 years now. And they work with communities very, very closely to make sure that they understand what's going on. They are not engineers. In fact, they are community mobilizers. That is their sort of remit. And so working with the community and working with everybody within the community, the gatekeepers as well as the rest of the community members. And I think for me, that's the important thing. I think you have to review and analyze as you go through a project and see what impact you're having. But I don't have necessarily the right answer for that. But I think, let's say, working with local organizations and community-based organizations from the bottom up, I think is, from my experience, is sort of how we've been approaching it, and it seems to work reasonably well.
That probably moves quite nicely into the next question, which is how does industry get involved with achieving these goals?
That's a good question. I think industry has lots of opportunities to get involved with them. I think there's a lot of opportunity for working with communities, and communities require services at the end of the day. They require services. We require services to cook, to clean, to wash, whatever else. And so being able to interact with that and be able to understand what those services are. And I think industry being able to partner with local organizations and even local industry and sharing knowledge around, I think that's one strong way that sort of industry could, UK industry can partner then with the local industry in whichever country you're working with. And if you've got products, if you've got ideas and concepts that you can work with then with there, I think that for me is the most sustainable way forwards.
And not to put you on the spot, Sam, but in terms of yourself and your own research, how do you see yourself working with industry or external organisations? I guess
in terms of external organisations, I've been partnering with a number for quite a few years now. In terms of sort of direct industry, I've not really done a lot of research with industry looking at how to enable these transitions. But I think there's real opportunities for industry to develop almost new streams for them in terms of almost a service-based or a knowledge-based stream, and especially with something like design for localization, where you could you could develop a concept or an idea that you could produce and publish open source and work with local industry partners to be able to actually to enable them to build it. And they can build it under license, so you can build however you want to work with that. And so I think that I'm really interested in how industry would be willing to be able to do that, and how you would want to work to do that. Because I think that there are a huge number of products out there. I think the other thing is thinking about, we don't often think about what do the poor need, what do the global poor need in terms of services and products, and how can we support them through that. And that doesn't mean that you have to not make a profit. There are a number of growing companies, especially in the energy access world, that are for-profit companies delivering energy access products. So, for example, Bbox, that came out of Imperial College, are now all over the world providing energy access through solar home systems, and have moved on into cooking systems as well. And so I think that there's a real opportunity there to be able to provide services to the poor or across the world, and they still require these services. They still want to have access to these services as well.
Thanks, Sam. That seems to have come to the end of our Q&A for today, and so we'll bring this session to a close. So I'd first of all just like to thank everyone for attending and for your questions today, and thanks to you, Sam, for your talk. That was great. If anyone attending today has had anything of interest that's kind of risen to them, please do get in touch. Our industrial liaison office is here to assist with anything like that, and we will follow up with everyone after this week-long event to send out any contact details. So if you have anything that you think of after this session that you'd like to follow up with Sam, then you can please get in touch, and I think Sam's also got his email address there. So thanks again, and have a good afternoon.